Welcome to this in-depth video tutorial on the SHACAL encryption algorithm. Today, we will explore the inner workings of SHACAL, a cryptographic algorithm derived from the SHA family, primarily SHA-1 and SHA-256. Let's get started. First, let's understand the basic concepts. Cryptography is the practice of securing information through encryption, transforming readable information into an unreadable format. SHACAL specifically employs the principles of hash functions to perform secure encryption. Now, let's list out what we will cover in this video. We'll start with installation, demonstrate how to implement SHACAL in Java, explore encryption and decryption processes, and finally, we'll discuss common use cases and performance considerations. To implement SHACAL, you'll need Java installed on your machine, as well as an IDE like IntelliJ IDEA or Eclipse. I recommend using Maven for managing dependencies effectively. Let's set this up. Now, let's create a basic Maven project. In the terminal, you can run the following command to create a new project structure. After running that command, you'll see a new directory structure created for your project. Open this into your preferred IDE. Next, let's add the necessary dependencies for our SHACAL implementation. Open the pom.xml file and include the following dependency for the Bouncy Castle library, which is a popular library for cryptography in Java. Now that we've added the Bouncy Castle dependency, let's create a class called SHACAL Encryption. This class will handle our encryption and decryption logic. To implement the encryption logic, we first need to set up the SHA-256 digest and HMAC. Let's define our encryption method next. In this code snippet, we defined an encrypt method that takes an input array and a key. We initialize the HMAC with SHA-256 and perform the HMAC operation on the input data to produce the encrypted output. Next, let's implement the decryption logic. Since SHACAL is a hash-based algorithm, the process for decryption may not be straightforward compared to symmetric algorithms. However, we can establish a means of verifying integrity and authenticity through HMAC. In this snippet, the verify method checks whether the calculated digest of the input matches the expected digest using the provided key. This ensures the authenticity of the message without needing a dedicated decryption process. With the encryption and verification methods in place, let's create a main method to demonstrate how to use these features. Now, when you run this program, you should see the encrypted byte array and whether the verification succeeds or fails based on the integrity of the data. Encryption algorithms can have performance implications, particularly when dealing with large datasets. It's important to acknowledge that while SHACAL is robust, understanding its limitations and performance when incorporated into your applications is crucial. Lastly, let's discuss some common use cases for SHACAL. Due to its secure nature, it's typically used for 1. Digital signatures, ensuring the message integrity. 2. Secure communications, protecting sensitive information across networks. 3. Data integrity verification in databases. To summarize, today we covered the SHACAL encryption algorithm, discussed how to implement it in Java using Bouncy Castle, demonstrated both encryption and integrity verification processes, and reviewed some of its use cases. I hope you found this tutorial informative and engaging. If you have any questions or require clarifications, leave a comment below, and I'll be happy to assist you. Don't forget to like and subscribe for more tutorials on cryptography and other software development topics.